This is Physics Optics video number 4. As you could probably guess here, I have the light box that I've been using for some of your other demos, and it's shining through a red filter right now. It's making a spot of red over here on the top of the cooler. And so again, the reason it's red is because the red filter only allows red light to go through it. So the white light's composed of blue, green, and red. And if it doesn't allow the blues and greens to go through, only the red's going to show up there, which is what's happening right now, more or less. So here's my question for you. If I take a green filter, this one's green, you can see. I'm going to put a green filter in front of this red filter that's over here now. What am I going to see on the screen? Okay, so think about that for a second. You might remember that the other day we did red plus green equals yellow, right? But you also might be wondering, hey, you know, this is physics and he's up to something. So and I am up to something, right? So if I put the green filter right in front of the red filter, I don't see any color at all. And I can go back in here, take the green filter off, and show you that I'm not doing any other funny business besides that, right? It's still the green filter, right? And so in this case, it looks like red plus green equals nothing. Or is it? Well, remember, there's a difference between subtractive color addition and additive. What I'm doing right now is another aspect of subtractive mixing. So if I put a green filter in front of a red filter and shine white light through it, there's nothing left to get through it because the red doesn't allow any green to go through it and the green doesn't allow any red to go through it. And so between the two of them, nothing gets through. So if I had red light and green light, like you'd seen the other day, of course you'd get yellow, but in this case you don't get anything because, again, it's subtractive mixing. Okay, so that's the last thing with color that I want to show you, but I have some things with lenses because lenses are also very important in terms of optical illusions and how your eyes work. So I want to show you a couple things with lenses here yet on this video, the last one for the first Cyber Week. And there's a challenge at the end with this. You have to predict an answer, write it in the comments, and we'll see if you're right or not. Okay, so here we go. So what I'm doing right there is I put 3 slits in front of a fairly focused beam of light, and you can see that there's rays coming out of it right now. So what I'm going to do is I'm going to put some different lenses in front of it, and we're going to see what happens. Okay, so the first one probably looks a little bit more like a lens to you, and that's this one right here. And I'll put it right in front of it and see what it does. Okay, so here we go. And if you can see what's happening there, if I don't put my hand in front of the camera, that all the rays are converging at a point not too far away from the lens. So they're all bending as they go through it, and they're all converging at a certain point. That distance from that point back to the middle of the lens is called the focal length. Okay? So getting a little bit closer with it so you can see it. And if I move this around just a little bit, you see that focal length, it doesn't really change depending on how I orient this thing. That distance in there, that little distance, stays about the same. Okay? So I'm going to try a different lens now. This is a sort of a hemispherical one, semicircle. Put this in front of it this way, right? And you can see it's got a little different focal length than the last one did. The distance from its center out to where all the rays converge is a little bit longer than the last one. Okay, so that's a different focal length than the first lens. And you might guess why. It's because that had 2 curved surfaces. This only has 1. The other side of this one's flat. So all that bending that occurs only occurs at the one surface really where it's aiming towards the light. So that's a couple different lenses. Let's see. Oh yeah, I have another one here. This one. That one also has a pretty long focal length. Maybe you can even guess why, right? If you look at it carefully, you can see that it's not curved quite as much as the other ones. And so having less curve means it's also going to focus light less rapidly. And so that's a kind of a lens that also focuses light. It's a converging lens, but it doesn't focus light quite as well as the other ones do. Okay, so coming up, here is your challenge. Okay, here's a lens, right? There's that lens. And here's the lens that I just put in front of it, that lens. In fact, I'll put them both in my hand at the same time so you can see them there. Okay. All right, these two lenses. What do you think will happen if I put both those lenses right in front of the three parallel rays of light? I'm going to put them both right together, right, kind of like that, right? So I'd like you to write your answer in the comments section. What happens if I put both those lenses together just that way? Will it still converge? Will it not converge? Will it converge further away? Will it converge closer? That's up to you, okay? But you can see how they are in relation to each other in my hand right now. And that's the answer that I'd like you to have for me in the comments. Do you think, what do you think is going to happen if I put both of those in front of those three parallel rays of light? The same three rays of light that you see right there. Okay, so that's the end of that. Again, the next week, there's a new homework assignment, There's a new homework assignment posted for you. And then also we'll be working on our optical illusion presentations. And we'll also be doing a Google Meet as a class at the beginning of next week, your first class. That's how we'll start, and I'll send you an invitation for that. Okay? All right, so have a great weekend, everybody. Don't forget to post that in your comments, and see you.